Okay. We are recording. So last time we were seeing the writes. I'm going to continue with the write and explain a little more over the writes that we have in a Unix system. So we say that we have something that is called a mod that is associated with a file. When I say file, it's any type of file. No, it can be a directory, an ordinary file, a special block file, a special character file. It can be a soft link. Okay, it can be all we have in a Unix machine. So the modes are divided in owner, group, and others. So we have 3 writes for each one. And those writes are read, write, execute. So we will see R when we have the read, write, W when we have the write, write, and X when we have the execute, write. So when we look at a file, we will have the user write or the owner write, then the group write, and then the others. So if you have an R here, it means that the user can read. If you have a W here, it means that the user can write. If you have an X here, it can mean that the user can execute. And here we control the read, write, execute, write of the group. And here we control the read, write, execute, write of the other user. So if I am the owner of the file, this is the right that are going to be applied to me. We are not going to consider this right if I am the owner. Now, if I am not the owner, but I belong to the same group as the file, this is the right that are going to be applied to me. And if I'm not the owner, I don't belong to the same group as the file does, I will have those rights, which correspond to other. So it's either this one, or this one, or this one, no, as we saw last time. So let's see the difference between the write on a file and the write on a directory, on a regular file, ordinary file. So when you have the write permission, the read permission, sorry, you can do read operation in the file. So for example, you can use command like cat, more, less, grep, because you can see the content. You can apply read operation over the file. Now, when you have the write permission, you can do write operation. For example, you can change the content of the file using the echo command where you redirect the output to the file. You can do that, for example. When you have the execute permission, so it will depend if the file that you want to execute is a binary file or if it's a script. If it's a binary file, you just need the execute permission and you will be able to execute the file. Now, if it's a text file that must be interpreted by Python or Bash or any other interpreted language, you will also need the read permission. You will need both to execute the file, the read and the execution permission if you want to execute a script. Now, let's see those writes at the level of a directory. So when you have the R write, the read write, at the level of the directory, it means that you can have a listing of the content of the directory. You can search also inside this directory. Now, having this write alone is not useful. If you have the read-write, you need the execute-write also. So the read-write alone is not good of a directory. You need the execute-write. Now, the W-write of a directory will allow you to add new entry in the directory, new file, new directory, for example, or to remove entry that already exists in the directory. So remove a file or remove a directory. Also, alone, the W-write does not make any sense for directory. If you have the W-write, you also need the X-write over the directory. And the X-write will allow you to enter a directory, which means to use the command cd and go inside the directory. Or it will allow you to traverse the directory. So this one, we can have it by himself, the execute write. So for file, thing that makes sense is, for example, this, dash, dash, dash. If you have dash, 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 you have no permission on the file. If you have r dash dash, you have read permission, which means you can cut the file, you can use the more command on the file, the less command on the file. You can see the content in general. You can also have dash w dash. So you can execute write command on the file, which means that, for example, you can use the echo command and redirect the output of the echo command into the file. So you change the content of the file. If you have only the execute write, you will be able to execute a file if it is a binary file. But if it is a script, you will not be able to execute it. So another one that makes sense is rw dash. So if I have rw dash, I will be able to read the file and to write the file, which means that I will be able to see the content, modify the file, edit the file with an editor. Here, I'm not able to edit the file with an editor because I don't have the read permission. But here I will be able to edit the file with an editor. If you have the read dash execute permission, you will be able to read the content of the file and you will be able to execute it. So you will be able to execute it in both cases, if it's a binary file or if it's a script. And if you have read, write, execute, you have all the permission on the file, which means that you will be able to see the content, modify the content, and you will be able to execute the file if it's an executable. Over directory, what makes sense is this, which means that dash, 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 no permission. If you only have the X write, you will be able to go inside the directory or traverse the directory. Another that makes sense is r-x. So in this case, you will be able to get a listing of the directory, search inside the directory because you have the r-write. And with the x-write, you will be able to go inside the directory with the cd command and traverse the directory. Another that makes sense is dash wx. So in this case, on a directory, because you have the w-write, you will be able to add new file or directory, or to remove existing file or directory. And you will be able also to go inside the directory, because you have the x-write, or traverse the directory. And here you have all the write. You have read, write, execute. On a directory, it will allow you to get a listing of the directory, search inside the directory, add entry to the directory, remove entry to the directory, be inside the directory, traverse the directory, all the writes. So let's say that I have a directory that is called D1. Inside the directory D1, I have a subdirectory that is called dir2. Inside dir2, I have another subdirectory that is called dir3. And inside dir3, I have a file that is called file.txt. And I want to execute this command, cat. This is the absolute path name, no? What write do I need for this command to be successful? So I need you to tell me what write do we need on D1, on directory 1, on directory 2, on directory 3, and on the file. So let's start with directory 1. Which write should I have on directory 1? Okay, we are going to do it. We have the virtual machine. We are going to the virtual machine and create this directory. So I'm not using that anymore. So let me see if I'm root here. I'm Sally. By the way, Sally is in the group of John. Let me remove Sally from the group of John. I want Sally to be just in her group. So when I want to remove a user from a group, I can use gpassword, which is a command, -d for delete the user Sally from the group John. I think I don't have the sudo setup, so let me just switch the user. I'm going to redo the command. Let me just copy it where it is. Okay, let me retype it. So group password -d, remove the user Sally from the group John. We did that last time. So remove user Sally from group John. Now, if I ask, show me the information of Sally. So Sally, this is the user ID of, she is Sally. Her primary group is Sally, and the list of group that she belongs, she just belongs to the group Sally. Okay, so now in this window, I will be root. So we can identify it easily here because it says you are root in this group, in this window. Let me create the first directory. 1, inside dir1 I create dir2, inside dir2 I create dir3, and inside dir3 I create a file. According to the exercise, it was file.txt, no? File.txt. I'm going to create a file, and I'm going to put some content inside. Let's put hello, for example. Okay. So I have this is security. CS470.
It's 363.
Sorry?
That's 363. Okay.
Okay. So I am the root user, and I'm going to use the cat command to see the content of this file. We know that in this file, we have just one word that is say hello. So as a root user, I never have limitations. Now, we are going to have other windows. For example, here, let me see who I am. I am the user Eric. So Eric is a normal user. And here we can see that we are the user Eric. So I want Eric to see the content of this file. Will Eric be able to see the content of this file? And what is the minimum privilege that Eric needs to see the content of this file? So I want Eric to do the same thing, cat dir1, dir2, dir3, and there is a file that is called, I want to do that. So what will be the minimum write that Eric need on dir1 to execute? this command and for this command to be successful. So I need to traverse the directory. When I need to traverse the directory, what is the write that I need over this directory? The X write. The X write allows you to go through the directory and to be inside also if you want. If you want to do cd/d1, you need the X write. So let's see the write of D1 over D1. Look at this is the write of the owner. The owner is the root. Those are the write of the user that are not root but belong to the root group. So Eric is not root. Eric does not belong to the root group. You remember I did the command ID. I belong to this group. Or I can, to make it a little clear, I belong to all this group. I don't belong to the root group. So these writes are not the one that I'm going to use. I'm going to use those writes. So I do have the X writes. So to show that the minimum write that we need, let's remove the R write here. How do I remove this R for Eric on D1? What should I do? On change mode, we can do for the other user, remove the write R over dir1. So now if I look at the write that Eric have over dir1. --x, which means that Eric can go inside D1. I am inside. But Eric cannot get a listing. To get a listing, I need the R write. See, if I try to get a listing, it's a permission denied. And I can pass through it. For example, let me go to inside dir2. So here I am inside dir2. So as you can see, the X write allow me to be inside the directory or allow me to traverse the directory. So let's go back to my initial question. I'm the user Eric, and I want to execute the command cat dir1, dir2, dir3 file.txt. So we know that the minimum write that I need here is the X write over this directory. What is the minimum write that I need over this directory to do this command? Also the X write. I just need to pass through this directory. So if you look in this moment on this directory, those are my writes. Eric have those writes. So I have more. So let's put the minimum write. So I'm going to change the mode, and I'm going for the other user, I'm going to remove the write R. So if you look now, we just have the X. Okay, Eric just have the X because this is the write of Eric on this directory. Okay, what is the minimum write that Eric need over this directory to execute this command? So the possible write are R, W, and X. Do I need the R write on dir3? If I have the R write, it will allow me to do what? To get a listing. For example, to search for file inside the directory. This command is not give me a listing of the directory. This command is show me the content of a file. So I don't need the R write on directory 3. Do I need the W write? No, the W write will allow me to add a new file or to remove a file from this directory. So I don't need. So the only write that I need is the execution write. The execution write will allow me to be inside or to pass through it. To reach file.txt, I need to pass through directory tree. So I just need the execution right. Let's see what I have for now. I will have the read and the execution right. No, as you can see here, in this moment, Eric have both right. We can just say, okay, for the others, we just want the execution right. And look, for the others, we just have the execution right. So now, over this file, what must be the right of Eric to see the content of this file? Now, we are not talking about right over a directory, but right over a file. So, three possibilities, RWX. If I have the R right on a file, it allows me to do what? To see the content. With this command, what I'm doing is what? I'm getting the content. I'm seeing the content on the screen. So I do need the R right. Do I need the W right to do this command? No, because the W right of a file is what? To modify the content of the file. I'm not going to modify the content. Do I need the execution right on this file? No, because the execution right is to execute the file. This is not an executable file. This is a text file. I can just show its content or modify its content. So I just need the read write on the file. Let's see what write we have on this file in this moment. We have the read write, just the one that I want. So this command should be successful for Eric. Look, I can see the content. Now, let's see that this is the minimum. Here I only have the read write. Let's remove the read write for the other user. And we will see that Eric will not be able to see it anymore. So change the mode, and for the other user, don't give any write. So look, I used to have R dash dash, now I have dash dash dash. Let's see if I can see the content of the file. Should not be able. Look at the command, permission denied. I cannot see the content. So it's a way to show you, you need the R right, at least. Let me give it the R right again. Let's verify it. So we have R dash dash, as you can see for Eric. So now if I come back and I ask the content of this file, no problem. Now, we say that for the tree directory, we need the execute write. Let's verify that if you remove the execute write, this command will not work. So for example, on directory tree, Eric have do's write dash dash X. Let's remove the X. So I'm going to say change mode. And I want for the others, I want no write. Let's verify. So now Eric have on this directory, which is dir tree, Eric have dash dash dash. So it should not be able to type this command. Look at permission denied. You see? Of course, I should be able to go inside directory 1. I am inside. I should be able to go inside directory 2, but I should not be able to go inside directory 3 because I don't have the execute write anymore. So if I try, permission denied. You see? Because you remove the execute write on directory 3. Let me put back the execution write on directory 3. Let's verify it. So now Eric have only the execution write on the directory. It have dash dash execute. So if it tried to go inside, it should be able. Here I am. If I want a listing, I will not be able because I don't have the R write. Okay? Let's see another example. Okay. Now, I want to remove the file. So look at the command, remove. We give the full path of the file. To remove the file, what are the minimum write that Eric needs for this command to be successful? So what will be the write, the minimum write on dir 1? X, correct. On dir 2? X also, because I just need to pass through it. On dir 3? What are the minimum write that I need on dir 3 to remove this file? So we have three possibilities in a directory. R, W, X. What does R mean for a directory? I can get a listing of the content of the directory. What does W mean of a directory? I can add or remove entries in the directory. Adding is creating new file or creating subdirectory inside this directory. Removing is removing file or removing subdirectory. So on dir 3, what should be my write? My minimum write for this command to be successful. I need W and X. Why W? Because I'm going to remove a file that belongs to this directory. So I need a W write. And why I need the X? Because the file I have to pass through this directory to reach the file. So I need W and X. If I don't have W and X of a directory tree, I will not be able to remove the file. What are the write now that I need over the file? Per C, the file.txt to execute this command of removing the file. I don't need any write. Remember, over a file, you can have three write, R, W, X. R mean what? You can see the content of the file. If I remove a file, I don't need to see the content of the file. A W mean what? You can change the content of the file. An X mean what? You can execute the file. So when I remove the file, I don't need to read the content of the file. I don't need to modify the content of the file. I don't need to execute the file. So I don't need any write over the file. So let's try it with the minimum requirements. So let's see over the file first. Over the file, Eric have R dash dash. We say that it doesn't need any write. So let's limit even more its write to verify that it doesn't need any write. So let's put change mod. We can do order minus R, or we can do order equal nothing. So look, now Eric on the file have dash dash dash. It doesn't have any write. Remember here I am root in this window. When I go to the other window, I am Eric. So let's go back to directory 3. What are my write on what are the write of Eric on directory 3? On this mode, it's dash dash X. So Eric should not be able to remove the file. Let's try to remove the file. And let's see that we cannot do it. Let me go back to my home directory and let me try to remove it. Should have a permission denied. So it say it asks me to confirm if I want to remove it. I say yes, remove it. And it say permission denied. So the file is still there. I could not remove the file. Here is the file. It's still there. Why I could not? Because I don't have enough write on directory 3. I need a W write. Now, let's say that on directory tree, I only have the W right. So let's see. Look at my right here. Normally, this is a nonsense. If you put W, you should put X. So here we have dash, W, dash. So I am not able to go through directory tree to reach file, the file that is inside. So if I want to remove it, let me put the force command, the force parameter. Permission denied. Doesn't allow me to remove it. So if I have only the W right, I cannot remove it. If I have only the X right, I cannot remove it. Let's put both right. So X, W, and X. Let's verify them. So I have dash, W, and X on directory tree. Now I should be able to remove the file. Look, it doesn't say anything. It did remove the file. So if I look, the file is not there anymore. Let me get a listing. There is no file inside. Let me create the file again. File.txt. And let's put inside, for example, at the beginning we put hello. Let's put how are you this time. And we want, okay. So it was to verify that the minimum right that I need is the one that I told you. Let's see another exercise. Let's say that this one this time I want to make the third command. Make dir D1, dir2, dir3, new dir. I'm creating a new directory, which is called new dir. And it's a subdirectory of directory 3. So what right I need over directory 1, directory 2, and directory 3 to make new dir? What do you think? What minimum right I need over dir1? Here, over this dir1?
Execute.
Execute. Over dir2? Execute. Over dir3?
Execute.
I need W and execute. Remember the W allow you to remove file and directory inside the directory or add. So since I need to remove a directory, I need W and X to do this make directory. If I don't have the WX right on directory 3, I will not be able to make the directory. I need both right. So let's verify it. So let's check the right that we have in this moment on directory 3 is we have both. So it will allow me this moment creating, no? So if I try to create a directory here, new dir and make dir, it did create it. Of course, I am also able to remove it. It did the operation without problem. Now, if I just have the X right, let's change that to the X right. I will not able to do it. So change mode. The other user have just the X right. Let's verify. So the other user have just the X right. Now with the X right only, if Eric tried to make the directory, it will not be allowed. Permission denied, as you can see. Why? Because I don't have enough right on directory 3. I just have the X right and I need the W and X right to create a subdirectory inside directory 3. Let's see another one to get used to the right and understand how they work. Okay, I need a listing of directory 3. What right I need to get a listing of directory 3? So what write should I have on directory 1? On directory 1, I just need X. What about directory 2? Just X. What about directory 3? I need R on X, because R is the one that allows me to get a listing. So I need R on X. If I don't have R on X, I will not be able to execute this command successfully. Okay, let's see that we need both right for the command to be successful. So in this moment, let me see. Okay, Eric have only the X right in this moment on this directory. So if he tried to get a listing, we already show that. Permission denied. Now, if I add a right to the others, we change mode, other plus R. Now we have the R on X right over directory 3. So now if I try to get a listing, I have it. There is only one file inside, which is called file.txt. But I have no problem to get the listing. Now, look, if I only have the X right, the read right, let's see that I'm going to change it and I'm going to remove the X right. So here I have only the read right. It will misfunction. I have the read right, I don't have the write right and the execute right. Look what will happen if I ask a directory. It doesn't work well. There is a misfunctionment, because if you want to have a listing of a directory, you need both. You need the read right and the execute right. Let me put the execute right back for the other user. Eric belongs to the other user. Look at the rights. Eric have read and execute right now. Do the command again and there is no problem. He get the listing without problem. Okay, so now let me see. Should we make one more exercise of that? What about this command? Echo hello, and we redirect the output of the echo command into the file which is there. We give the absolute path, which is /dir1, /dir2, /dir3, /file.txt. So what right do I need over dir1, dir2, dir3, and file.txt to do that? So here we have two versions of the same exercise. Here they say if the file already exists and if the file does not exist. So if the file already exists, let's say that file.txt already exists. What is the minimum right that I need on dir1? X. What is the minimum right that I need on dir2? X. What is the minimum right that I need on dir3? So are we adding an entry to the directory or removing an entry? No, because the entry already exists. The file is already there. So we just need the X right on directory 3. What about the file? Which right do I need on the file? The minimum right will be what? The W right. I just need the W right on the file. So let's see that. So we need XXX for the directory and W for the file, just that, and it will work. So let's verify. On directory 1, I have just X. Eric have just X. On directory 2, Eric just have X. On directory 3, it have in this moment read and execute. Let's just put X. So let me change that. Change mode, others, -R. So if I look on directory 3 now, Eric just have X. And then on the file per C, let's get the right on the file. Eric have the read write. So if he try to do this command, it will not work because the write that he need is the W write. So let's try to do the command. So the content of the file, I can see the content of the file as Eric. Let me see the content. It say, how are you? So let me try to change it to, for example, I am okay. And it will not work. Permission denied. If I look the content, it still say, how are you? I didn't change the content. So let's now modify the mode of the file. Change mode, and I want for the other user just the W write. Let's verify it. As you can see, the other user, Eric belongs to the other user for this file, just have the W write. So this time it should work. So let's do it. As you can see, no warning. And if I look the content of the file, oh, I don't have the write because I don't have the W. So let's make the root, check the content of the file. I am okay. So I did change the content of the file. I don't have how are you anymore. I am okay. You see? Okay. So let me continue with that. So we saw the command change mode. We saw that we can use, when we use the command change mode, we can use the letter U, G, O. U for user, G for group, O for others. On the right are RWX. We can add write, we can remove write, or we can specify exactly the write that we want for the user or for the group or for the other. Okay, so remember this, we can also work with octal number. So if you want the write to be 744, what will be 744? What will be the write at the level of the user if I use 744?
Read, write, and execute.
Exactly. Read, write, and execute for the user. So 4 for the group will be what?
Just the read.
Just the read. And for the others, just the read. Now, if I do 755, so the user have read, write, execute. What about the group? Read, execute, and the others read, execute. Okay? So this is an octal number. Okay, there is something that is called the UMask. Before we continue, I want to explain you what is the difference of the execute at the level of a file. So let me be user Eric. Let me go here. We are going to do a program in C that will show, for example, let's call it show triangle. And if we put 3 as a parameter. We want to show a triangle. So this triangle will have in the first line 1 star, in the second line 2 stars, and in the third line 3 stars. So if I call the command, let's say show triangle with 5, it should show me 1 star in the first line, 2 star in the second line, 3 star in the third line, 4 star in the fourth line, and finally 5 star in the fifth line. Okay, this is what I want. So I specify the number of rows that I want. On each row, if you take row I have I star. So for example, row 1 have 1 star. Row 2 have 2 stars. Row 3 have 3 stars. So let's do a program in C that will do that for us. I'm going to edit with my editor. You use Nano, for example. I use VI. I'm going to edit a program that is called show triangle.c. Okay. Help me with that. What should I put here? Going to include standard input output.h. What else? Have the main function. Since we are passing argument, which is the number of rows, here 5, I need to check that the person enter the number of rows, no? So let me put here a return 0. Okay, so I need to specify that I'm going to have argument the first thing that I'm going to say, if the number of argument is different of 2, there is a problem. The person has to pass exactly 2. The name of the command and the 5. So I'm going to tell the person how to use the command. So let me guide the person, print usage. Sorry, it's printf. I better do fprintf. And I'm going to send that to the standard error. Okay, usage on one line. On the other line, I'm going to tell the person, you first enter the command name and then the number of rows. Num rows. And the command is in argv sub 0. And then I will exit with 1. When there is a problem, the return error will be 1. Since I use the exit function, I need also to include stdlib. Okay, let me compile this program and execute it.
On the fprints, it says SDT instead of the STT.
Thank you, you're right. Okay, so what is that? I need a okay, I need another one. Let me make it a little smaller. Okay, I'm going to compile it. So it is in the desktop. Do I have the C compiler? Yeah, I have the C compiler. So GCC-O for the output. I'm going to call it show triangle, the executable. And the source is show triangle.c. So didn't like it. Let's see. Standard error usage. They say there is a problem. Oh yeah, I forgot here the semicolon, and here the semicolon. Okay, let's compile it again. It did work. Let's execute show triangle. So there is another problem here. Usage, it's okay. And percentage S, I see it okay. And exit one. If it's different of 2, oh, there is a star missing here. It has to be an array of pointers. Let me execute it again. Okay, so if I don't specify the number of rows, it shows me how to use the command. And of course, if I look, the error status, it has to be 1 because I exit with 1. Now, if I put the number of rows, the error status should be 0. It is 0 because I return 0. Okay, that's fine. Now, let's do our triangle. So let me define a variable that I call num_rows. And I'm going to use this function, ASCII to integer, and convert argv_1, which is a string, into an integer. Let me see, man, ASCII to integer, should I need to include the standard lib, it is already included. It is already included, okay. So now I can just do two nested for I will be the row. I start in 1, I less than or equal to num rows, I plus plus. What should I do? So I need to show I stars. So I'm going to put a nested for, controlled by j. I'm going to start in 1, j less than or equal to I, j plus plus, and inside I'm going just to print 1 star. And after doing that, before going to the next line, I'm going to print the next line. By the way, it's not print, it's printf, no? In C, it's printf. In print in Python. Okay, let's compile that to see if it's work. Okay, compilation was right. Let's execute it now with, for example, 5. 1, 2, 3, 4, 5. Good. Let's execute it with 10. Okay, so it's work. So look, what is my write on this file? This is a binary file because I compile it. Look, Eric have this write. And I say the only write that I need to execute this file must be the X write. So let's change this command to just have the X write at the level of Eric. And the group on the others should have no write. So what should be the binary, the octal that I put here? What should be this octal? If I just want dash dash execute dash 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 dash, what should be the octal? One zero zero, isn't it? Let's check the write. So look, we have dash dash x dash 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 dash. So Eric, I am Eric, can execute this program, and this is the only write that Eric have. It should work. So let me execute it with, for example, 15. And as you can see, it's work. Now let's do the same program in Python. So let's do a show triangle.py. So help me with that. Let's put the hash bang user bin Python 3. Let's import sys. If the length of sys.argv is not 2, you need to guide the user. So let's print usage. And I want that in our error. Okay, after showing the usage, I'm going to show the name of the command, following by num row, number of row. You have to specify the number of row. Okay. Percentage S, I want to replace it with sys.argv sub 0. And I want to exit, for example, with 1. And if everything is okay, I want to exit with 0. So this should be working okay. We can just verify it that it worked okay. So here, let me change my write on this file, show triangle.py, and let's execute show triangle.py with nothing. So if I say nothing, it gives me how to use it. If I look at the return status error, it's 1. And if I say an integer after, it doesn't say anything and it's returned with 0. Okay, it's okay. So now I need to show the triangle per se. So I'm going to put a for I in range. I start in 1 and go up to, let's define a variable that is called numero. So the number of row, I have it in sys.argv sub 1. And since it's a string, before I use it, I convert it to an integer. So I will go from 1 to up to num rows plus 1, which will be excluded. You remember, the 1 is included, the numero plus 1 is excluded. So from 1 to numero. And every time that I pass, I will print a star I times, and that's it. So this should be working. Let's try it. Argv dot here. I put a comma, it's a dot. Let's do it again. 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it does work, as you can see, no? We can try with 3, it does work. So what is my minimum write on this file to execute it? It's different when it's a binary executable that when it's a plain text executable that must be executed with an interpreted language. So my minimum write must be Rx. So look at the difference. If you look at this one, which is a binary executable, I just need the X write. But on this one, I will need the R and X write. So let's check it. Let's, for example, at the beginning, put just the X write. So 100 for show triangle.py. So now, in show triangle.py, I just have the X write, and I will not be able to execute it. Let's put 10. Look at what it says. Can't open file. Permission denied. Because it tried to open the file and read the content. So I do need one more write. So if I need read and execute, I have to put 5. Let's see. Now I have read and execute write. I should be able to execute it. So you see, it's different. If it's a text file, you need read and execute writes to execute it. If it's a binary file that you compile with, for example, C or C++, you just need execute write to execute it. Okay? Any question about it? Oh, that's fine. Let me continue and see other important thing that we need to know. Okay, there are another three writes that exist in Unix, which is the set user ID, the set group ID, and the sticky bit. So let's talk about each of these three writes. So the set user ID can be applied only on a file. And it will change the behavior of executable file that are binary file, not executable file like the one of Python, which are script. So here it say cannot be used on shell script. It can only be used on binary executable. And what it will do, it will change the user that is executing the file. So, for example, let's say that this file, it's an executable file, belongs to the user root, and Eric executes the file. So the real user will be Eric. But while Eric executes this file that have the set user ID bit set, it will have extended rights. And those extended rights will correspond to the right of the owner of the file. In this case, we say the root. So it will have this extended right. We will see that. Okay, the set group ID rights can be applied to file or to directory. So if you apply it to files, the group is going to change while you execute the file. So initially, a normal user is going to execute the file, and the real user will be the normal user, but it will get extended rights because it will change its group from its group to the group where the file belonged to during the execution. So this is when you apply it to file. When you apply it to directory, it will, if you create a directory or a file inside the directory that have this right, it will change the behavior of the directory that the file or the directory that you create will belong to. So normally, if the user Eric that belongs to the directory Eric create a file, this file will belong to the group Eric. Now, if you change the set group ID of the directory where the user Eric do that, it will get the same directory as the directory. It will change the group as the group of the directory. Okay, and we have the third permission, which is the sticky bit. So the sticky bit only apply to directory, and it will allow user to create files and directory inside this directory that belong to them. And they will not be able to remove the file and directory of other users. So I know that it's not very clear, I'm going to show you how we work on that, no? So look, now the X that appear can change in a S here. When it changes in a S, it means that we have the set user ID set. We have set the user ID. The X of the group can be changed to a S, which means that we have set the set group ID. And the X of the other can change to a T, which means that we have set the sticky bit. So the sticky bit is a little easier to understand, so I'm going to start with the sticky bit. So here you can have S instead of X. You can have X instead of X, and you can have T instead of X. So sometimes you will see capital letters, capital S or capital S or capital T. When you have that, is that you have a problem, because when you set the set user ID or the set group ID or the sticky bit, you also need the execution right. If you don't have the execution right, Unix will tell you that by putting this letter in capital, telling you need the execution right. So for example, if I want to set the user ID, I need the execution right at the level of the user. If I want to set the group ID, I need the execution right at the level of the group. If I need to set the sticky bit, I need the execution right at the level of the other users. So let's understand those additional 3 rights. So to change them, we will see that we can use octal numbers, but this time, up to now, when we put an octal number, we put 3 digits. This time we are going to put 4 digits. And the first digit, which will be between 0 and 7, will allow me to specify which one I want to set. So for example, if I set this bit in 1, I will specify that I want to set the user ID. If I put this bit in 1, I want to set the group ID. If I put this bit in 1, I want to set the sticky bit. So this is when I work with octal numbers. And of course, we can use the other method that we saw with the plus, the minus, and the equal sign. So let me explain you how it's work. I have to be root to explain you that. Here I am root. Okay. I'm going to create a file. I'll explain you. So where I am here, I'm in the root directory. Let me create a file, touch.txt, for example. And create a directory also, make dir special, let's call it. Okay, so let's see the write on dir special. So as you can see, we don't have the sticky bit. If I want to put the sticky bit on this directory, I can do, for example, change mode. Let's say that I want the rights to be read, write, execute for the user, for the group, and for the others. I will put that. And I also want the sticky bit. If I want the sticky bit, I have to put a 1 at the beginning. You remember that here we have 3 positions. And a 1 will modify the sticky bits. So look, if you look now, we have a T here, saying that we have the sticky bits. We still have just X here and X here. because we didn't set the user ID or the group ID. If I want the sticky bit on the group ID will be, I want a S here. What should I do as command? How do I change this command to have the sticky bit on the group ID? And set the group ID. I should put what? So look, if you want the sticky bit, you put a 1. If you want the group ID, you put a 2. 1 plus 2 is 3. So you need to put 3 here. Let me put 3, and let's see the rights. Look at now. Here we have the set group ID, and we have the sticky bit on the directory. So what is the sticky bit? Let me just put the sticky bit. So on this directory, let me move this directory in the roots. Here in the roots. And let's go inside this directory. Dear special. And we have the sticky bits, as you can see here. Since we have the sticky bits in this directory, all the users of the system will be able to create file and directory. And when they create it, it will belong to the user and group that each user has. For example, let me see. Here, I am Eric. I'm going to create a file inside this directory with, for example, touch, dear special. Let's create eric01.txt. I create a file. If I look inside this directory now, we will have this file. Dear special. We have this file. And look at. We have just the sticky bits. Oh, we still have this, sorry. I didn't remove that. Let me see that. Dear special. He didn't remove it. So let me do a group minus S. Okay, so we have read, write, execute, read, write, execute, read, write, sticky bit. Okay, so let me remove the file that I just create because I was not as I wanted to be. And let me create the file again. So if we look, we have a file that was created by the user Eric, which belongs to the group Eric. The user Eric can create directory. So let me create a directory. Let me call it Eric dir 01. And if we look, Eric was able to create Eric dir 01. It's belong to Eric, and the group is Eric. Now we have another user that is called John. So let me enter as John, and who I am here, I am Eric. Let me switch to be John. So the password of John, I think it was John. So now I am John. Okay, I'm going to create a file in this directory. So dear special, and let's call it John01. Yeah, John01.txt. Let me create another file, John02.txt. If I look at this directory, now we have the file of John that belong to user John, group John. We have 2 files for John, 1 file for Eric, and 1 directory for Eric. John can create a directory. Let's create a directory for John. So John dir 01. Make dir, let me create another directory. And if I look, now John have two directories. What will happen that Eric will not be able to remove the file of John or the directory of John. And John will not be able to remove the file or directory of Eric. So here I am John. I'm going to try to remove the file of Eric. So remove special, dir special, Eric 01.txt. Eric 01.txt. So I say yes, try to remove it, and it say operation not permitted, as you can see. I'm not allowed it. So the sticky bit can be used, for example, in this context. Let's say that I have a directory in a Unix machine, and I have a class, and I want all the students to put their report in this directory. So in the directory, I put the sticky bit. It will allow all the students to create file and directory in the directory that I want them to put the report. But it will not allow a student to remove the report of another student. They can just add their report. Of course, they can remove their report if they want. What means that what they have created, they can change it and they can remove it. But what another student have created in this directory, they cannot change it, they cannot remove it. For example, Eric cannot change the content of the file of John, and John cannot change the content of the file of Eric. Let's say that here I'm John, and I'm going to try to modify the report of Eric. So I want to edit this file. Look at what it said at the beginning, read only. It doesn't allow me to modify it. So let me try to modify it. You see, I put content inside. Let me try to save it. And it say, you cannot write the file because this is not your file. This is the file of Eric and you are John. So this is a way to protect. So now Eric do have the rights. If Eric want to modify its report, or I just realized that my report have a mistake and I want to modify my report, I can modify my report. There is no problem. Let's put this is the report of Eric and save it. I can see it was modified because I'm Eric, I'm modifying the report of Eric. But John cannot. For example, this is trying to add information here, trying to add and trying to save. Read only. You cannot do that. So you see what is a sticky bit? The sticky bit, when we apply it to a directory, it will allow all the users to create their own file, their own directory, but one user will not be able to mess with the information of the other user. It will not allow it to remove a file or to remove a directory that belongs to another user. Okay, so let's understand now what is the group ID of a directory. So on this directory here I'm root. Let me show you the information of the directory per se. On this directory, I do have the sticky bit, but I don't have the group ID. So I'm going to add the group ID. With change mode, group plus S. And if you look now, we have it here. So we have set the group ID. If I want to remove it, I can say group minus S. And if you look, now we have an X here. Okay? So I was telling, let me put it back. Group plus X, and we have an S. So I was telling you that if you forget to put the execution right, you will have a capital S. We show you that you have a problem. So let me, on this directory, put change mode group minus X. Look at the S, it's still there, but it's appear with capital letter. When it's appear with capital letter, it's because you have something that is inconsistent. You didn't put the execution right. So you need to put the execution right. Let me put it back. And you can also have a capital T, no? So lowercase s. In this moment, we have lowercase t. Let me show you how we can make a capital T. So for the other user, I remove the execution right. So look at it tells me there is a problem. You should not have a capital T, you should have a lowercase t. It's because you forgot to give the execution right. So let me give the execution right back, and we will have a lowercase t. So this is okay. What does it mean that we have the S bit, which is for a directory, which is the group ID? It means that if the user Eric now create a directory, in this directory that have the group ID set, previously it will create the directory in the group Eric, because I'm the user Eric. So look, when I create a directory, it was in the group Eric. Now, if I create a new directory, it will be in the same group as the directory group. So let's see what is the directory group. Oh, the directory group is here, is root. So let me create a directory as Eric. Here, special. Let's create Eric dir 02. So look at the difference. When I create Eric dir 01, it was in my default group, my primary group. Now, look at the group. It's not in Eric. It's in the same group as the directory belong. So if John, here in this window I am John. If John create also a directory, the same thing is going to happen. The directory will not be in the group John. It will be in the group root. So let me create a directory here as John, directory 3. Let's see all the information in the directory. So look at John, create 2 initial directory, and they belong to the group John. And the last one belong to the group roots. So let's say now I make this directory belong to Sally. So change group Sally dir special. So let's verify it first. Now it's belong to Sally. The group is Sally, which means that if Eric create a directory, let's create another directory as Eric, like directory 3, it will belong to the user Eric and the group Sally. So let's verify that. Look at it. I create a third directory for Eric. It belongs to the user Eric and the group Sally. So it don't belong to Eric. And if John create a directory, the same thing will happen. Or create a file, it doesn't have to be a directory. Let's create a file, for example, at the level of John, Let's create another file with the touch command. This file, which is there, belongs to the group Sally. Doesn't belong to the group John. So the group will be the same as the group of the directory where we apply the group ID. Okay, there is another bit that I have to explain you, but we don't have enough time to do it, which is the set user ID, which is the most important. And some files have it. For example, there is a binary file here that is called password and allow you to change the password. Look at it, have an S, very dangerous. When a file have an S, have the set user ID, it's a dangerous file because it means that when a normal user is going to execute this command, its user is going to be extended to the root user. Which means that when Eric use the command password, it's go from a real username, which is Eric, to an extended username, which is root. So I really execute it as if I were root. I am not root really. I am just Eric, but when I will execute this command, I will have extended rights. And this right will correspond to the user that is specified here. In this case, my right is going to be extended as if I were the root user, the administrative user. So it's why it is dangerous. This right is dangerous, and when we have an attack in a machine, a good practice is to find all the files that have this bit set. Also, all the files that have the group ID set. So there are commands that you can type, and you can say, please find the list of files in the system that have the user ID set or the group ID set, because they are dangerous. Okay, we are going to stop for today here. I see you in 2 days.